Hey, what's going on, guys? Coming again Z here. So I've just kind of managed to make two most essential things that you want from the chess engine. So parse FEN string in order to initialize the internal board and being able to actually print that internal board to the console. And obviously, what I also needed to do in order to deal with Chinese chess FEN strings is actually to increase the board size. So first, I'll quickly demonstrate the result I came up with so far, and then I would actually try to quickly walk through the steps I've been through in order to achieve this sort of a goal. So if I just build my version of Stockfish. So you see, like I've added some breakpoints because I don't really like to use the debugger. So instead, I'm just using breakpoints to make sure that every specific stage has been passed successfully. So here we are within the UCI mode, and Stockfish has additional non-UCI command to actually print the internal board state. So here we have the initial position being initialized here, and just to give you an idea, so you see, like I have the 11 by 14 array representing the chessboard, and the axes are the off-board squares, so empty squares are just empty squares, and this like pawn, 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 cannon, rook, knight, bishop, advisor, king, advisor, bishop, knight, rook, and same for black pieces. So just to find another, let's try this one. Just want to grab a random FEN, so just copy, and I say position FEN, so this is the UCI command. I paste it in and print the board again, and you see like the board position has changed. So now I can manually initialize the board array. So now let's go to the code. So this very simple and probably not really impressive thing is actually wasn't really that trivial to do, and I probably can't ever imagine yet how much pain I would have in order to eventually make it work. But anyway, so yeah, actually before we continue, so if I say, like, again, position start pause, just to restore start pause to initial position, and now let's say I can say position start pause moves and input a move. Well, it won't get recognized, but the idea here is that when we say position start pause moves, and then, well, let's say we want to say like h, so it's not really that correct now, so this move should be called like actually g2 to e0 if we just get rid of this off-board stuff. I just really wanted to show you this because in the next video already I'll get rid of this, and I would focus only on the board itself. And you see, like, there was no segmentation fall, which means that the move generator did a job and just didn't find the valid move because, yeah, I just disabled literally anything I could. But again, like, I just didn't have a seg fault after move generator being running. So just to prove that, so if we just go for oh my god, I forgot the name for a function. So let's search for this moves handling. Okay. Token UCI to move. Oh man, where did I? I'm just looking for a line that actually generates the moves. Some validation, man. I just, where did I? Okay, hold on a second. It just, is it not here? Okay, guys, I don't know. I just lost this function call. It was somewhere. It really was somewhere. So this is parse position. Yeah. I just want to say that the mode generator actually getting called here, and just to prove it a bit more, I can even call perf now. Let's say go perf1, and it doesn't have didn't search anything obviously, but it didn't also give an error. It didn't give segmentation faults. It just walks through the mode generation process, didn't do anything, and returned. And this is already, it's really awesome, guys. You can't ever imagine how awesome this is, basically. So that it's still kind of running. Okay, so nothing much to demonstrate here. So let's go to the types. So first, I've added new squares. I've changed the square number, and I've added pieces. I've added files and ranks, so we have more files and more ranks now. And also I've added new piece types. So okay, it's better to search for like this. So now we have also white advisor, black advisor, canon instead of queen, right? Okay, so this kind of additional pieces, and within the position CPP, well, this array is a weird placeholder to keep track of onboard and offboard squares, just by the lookup. So this line is from Stockfish, so but I've changed this to fit my piece layout, and this is actually needed to convert pieces. Well, actually, I just stopped being sure whether this is what I mean, actually. So the routine to set FEN. Oh, no. So yeah, I'm using the custom. And what was that previous array? I don't remember. I'm sorry for that. So yeah, I've added my custom logic for parsing position, so it's much more ugly compared to how it's done in Stockfish. I also would need to add kin square to keep track of to the position class. Didn't do it yet, so not really the most essential stuff at the moment, at the very least. So yeah, that's kind of it. And what else? So side to move is altered to make sure that either red or black both, or either red or white both would be treated as white. So if we have black, we do initialize black to move. Otherwise, whatever letter but B would be treated as the white to move. And well, castling writes just the FEN just gets parsed, so it's not really that big deal. I've disabled set state because I'm not really sure that if I actually need this entire state to deal with. Well, it's really hard to say at the moment, but just really relies on bitboards, kind of lots of bitboard code, bitboard related code there. And you know, like as far as I'm going to pure array-based representation, I'm trying to disable all the bitboard code I encounter. So for now, just disable this stuff. In peasant square is set to none by default, so I could have get rid of this, but just to make sure that if somewhere within the code the peasant square is getting kind of like, how to call it, man, getting accessed, that need to make sure that it is initialized actually in order to avoid any segmentation faults because of this stuff. Well, I didn't actually yet test whether all this stuff getting parsed correctly or not, because yeah, to be honest, yeah, I really need to check this out as well, because I'm not really sure that I'm shifting the pointer points into the string properly. So I actually did only care about the board position at the moment, so everything up to here. And color should be parsed correctly. Well, actually, yeah, actually this should be parsed correctly as well. Yeah, so actually this should be, well, anyway, it needs to be checked that out when it comes to something more serious. And yeah, also I've changed the routine to print the board. Don't reference table bases because I'm not going to be using them, and really lots of stuff as well. But I'm just, yeah, so here I'm just literally printing the piece, and piece on is the function to get a piece from the internal board array. And one last thing, so yeah, this has been disabled from the previous video. So I disable all the bitboard related code in put piece, remove piece, move piece, and piece on didn't have that. It just didn't have that. Okay, and piece board, and here nothing changed, but actually now the square number is equal to 154. As I've been mentioning, which is 11 multiplied by 14. So this number of squares is now square number equals to 154. Okay, so yeah, that's kind of what we have currently. Yeah. So now this array is actually no longer 64 squares, but 154 squares. Yeah. So I didn't yet disable this bitboards because I'm not really sure if somewhere some code does rely on this sort of stuff. I don't need the piece count and piece lists and castling and all of this stuff are part of gameplay apparently and sign to move. Yeah, thread, probably state info, and I really don't need this just 960 as well. So yeah, don't really need that much, but anyway. And you know, guys, the major thing I'd like to emphasize is that with this approach, I've just started feeling the flow, and I'm no longer getting frightened by the upcoming errors. Really, lots of those, to be honest, but as far as I can actually manipulate the engine, like, well, for now at least this is done implicitly, like calling the functions, like say the mode generator. I'm really happy with this sort of a thing. So, well, probably just one last thing to demonstrate. So just go to, where's my mode generator? Actually, yeah, I have disabled everything here as well, but yeah, let's just say so breakpoint generate moves begin. Okay, and just the one for the end. No, it doesn't really, it's not really different, but when there would be some code running in between, this might be making some sense. And probably I would also convert this legal to pseudo-legal one, and my make move function would also be relying on I want the make move, or as it's called in Stockfish, do move function, to be responsible for this move legality checking. And probably in that case I can drop the state of check being tracked from the states structure. That is how it's currently done in Stockfish. Okay, so what I want to show now is when I run, so hold on a sec, parameter position unused. Oh, it's unused within the Mogen. Okay, doesn't matter really. So when I just call position start pause moves and then try to input some move, it should start the move generator. So I've been mentioning this in the beginning. So let's go position. Now I just want to demonstrate you that. So position start pause and bring the board, and let's say position start pause moves, and doesn't matter doesn't matter what move I do now, it doesn't matter really at all. But we see like the move generator actually starts. So it needs to generate the moves to figure out whether the move that I did input is actually correct or not. And if it is, then this move would be done on a board. And that's a really nice way to debug this, the make move function as well. So yeah, and then eventually I would be able to go to the perf testing. Still a little bit unclear regarding the move stack, because I don't know if I'm gonna be relying on the one that is actually used by Stockfish or not. It's a good idea generally. Well, it's I don't know how exactly am I supposed to be going for that. Yeah, probably that's the matter of the make move, right? Yeah, that's the matter of the make of the move function. So here we just need to generate moves and just return the move list. So the next thing to change would be the number of bits used in order to encode the source and the target squares. So this is probably a bit of a teaser for the next for the next videos. Also, yeah, I need to alter the code that actually prints the coordinates. Yeah, because yeah, I'll probably use my lookup array placeholder instead of crafting the square from scratch, which is more cleaner way like it's done in Stockfish. But I just want to have the proof of concept implementation first, and then going for predefined the code. So here it is. So the move, and you see like bits 0 to 5, destination square, 6 to 11, origin square, and so on, so on, so on. So this needs to be altered because, well, I don't know, probably I would even make all of this stuff from scratch, because I have a set of functions to actually deal with this sort of a thing, and I probably just can make my own functions and reuse them within the well, anywhere actually, everywhere I need. I think that might be the case. And yeah, so just need 7 bits instead of 6 for source and target square, because otherwise 63 is actually the most number that can be represented with the help of the 6 bits. So with the 7 bits we have more, and the biggest square would be, well, I just can't say this straight ahead. So let's say like 0, 1, 2, 3, 4, etc. This one is 154. This one 154 minus 11. I'm bad at math, so it would be more than 100 actually. Then 7 bits would be really enough to represent this biggest square, or maybe within this word representation this would be the biggest square. So I can't really say for sure. Yeah, probably this one, because it kind of prints reversed, but doesn't matter. Well, okay guys, so this is actually all I wanted to share with you at this moment. And today I didn't try to give up this project a single time. Just for comparison, yesterday I was trying to do this countless number of times. So I really hope that this current approach would actually lead somewhere eventually. At very least, what I can say that it starts being really fun to work, because I feel the flow. I do code, and I have what to do, and I understand what do I need to do next, and I can control the flow. And the most important thing here is that finally, like surprisingly, even though Stockfish is a damn big monster, still I already just based on my previous chess programming experience and the matter of writing several chess engines in different programming languages for international Western chess and for Chinese chess CNC as well, I already feel like even though the structure of Stockfish is really complicated, but I really already kind of feel like how it works. So seems like I have enough consciousness now to actually kind of like imagine in my head how the workflow goes, because without this, when you're getting an error, it's extremely difficult to actually even to imagine like why the heck is that happening. But when you imagine the general, the overall workflow, it's really easier to guess where the bug might be and start debugging. I don't know. I don't use debugger. I just use this. I'm just embedding print statements to keep track of the control flow. That's the more natural way for me to go. So yeah, that's kind of it. Well, okay guys, so this is it from my side. So I hope some next videos with the further improvements are coming soon. So until the next time, and take care.